Hello, this is Professor Seagraves, and I'm going to now walk through a refinancing decision spreadsheet, and we're going to start off by setting up our basic assumptions, and then we are going to work through the various calculations to take a look at the old loan and the new loan. We'll start off with a price on a house that we originally purchased for $300,000 with a loan to value of 90%, which means the loan is just going to be 90% of the $300,000, or the B1 times B2 in this case, giving us a loan value of $270,000. And now we're going to use the basic payment calculation function in Excel to calculate our monthly payment, but to get that we need the rate and the term. So the rate we're going to use in this case is going to be 6%, and the term we'll use 30 years. And the payment function is going to be equals payment, and then we open the parentheses and point to the rate field. It'd be 5. Got to divide that by 12 since they're monthly payments. Number of periods is going to be the 30 years, and then we're going to multiply that times 12 to get our 360 payments. Present value will just point up to the 270, and that'll give us a payment of $1,600.18, $1,618.79 per month. And then we have our annual payment will simply be that monthly payment times 12 for $19,425.44. And oops, sorry about that. And now we will continue on in our calculations here. We'll spread that apart a little bit so it's easier to see. And we're going to take a look at our new situation. Now we have the opportunity to refinance our old mortgage after a certain number of years, and this one we will go ahead and choose, let's say, 8 years. And first we need to know what the balance is. So how much are we going to get from the new bank when we refinance after 8 years? So we need to know what the balance is. And the balance for any series of payments is just going to be the present value of those remaining payments at that old contract rate, and that rate was 6% divided by 12, and the number of periods is going to be 30 years minus the 8 years. So we'll say 30 minus the 8 years, and then we'll multiply that by 12. We got to put parentheses around that. That'd be 6 minus the 8 years, so that we do our subtraction before our multiplication. And then we're going to just point to that original payment amount, the $1,618.79. Because that's how much the bank is going to get for the 22 more years. So the balance of that loan is $236,985.36. So that's how much we're going to want to borrow. So we've paid off and gone down from the $270 after 8 years to the $236, about $237,000. So if we're going to pay off this old loan, we're going to we would only do that if we're going to get a new loan at a better rate. So in this one we're going to use 4.5%, and we'll still do it for 30 years, going out this time as well. And we want to calculate what our new payment is going to be. So we are going to, and kind of another assumption here is we're going to assume we're only going to be here for 5 more years after. We're probably not going to be in this new loan for 30 years either. And it does matter. So, and we also need to figure out what it's going to cost to get the new loan. So we'll have some fixed fees and some percentage fees, a 1% origination fee, and we'll have some other fees that might be for things like appraisals and so forth. And this one we'll just assume a fixed dollar amount of, let's say, $800, and then we're going to see for those new fees and that percentage, what's that going to multiply times. So that 1% is going to be $23.69, because that's the amount of the new loan that we get. And we are going to have a new payment, and that new payment is going to be our new interest rate, the 4.5% divided by the 12%, or divided by 12. And then the number of periods is going to be, its new loan is for 30 more years, so it's going to be 360, which would be 30 times the 12. and that new loan is going to be for the payoff of the old loan. So our new payment is going to be $1,200, and that annual payment will be the $1,200 times 12. We'll just say equals, we'll point to that cell, multiply by 12, and we get 14,409, and that's how much we're going to pay per year with the new loan. So we're going to save about somewhere around $5,000 a year between our old payment and our new payment. So that's pretty good. So, and if you can already start to figure it out, we're only going to have to pay $2,300 up front plus the $800, so roughly $3,000 to get this new loan. So we'll figure that out. Oh, we got the equals in there twice, so we're going to take the 800, we'll make that a negative amount, and we'll also subtract the $2,369, so it's going to cost us $3,169.85 to get this new mortgage. And then each year we're going to save the difference between the old payment and the new payment. So we'll just take the 14,409 and we will subtract out that 19,425. Will give us a $5,000 is going to be our savings every year. That's pretty good. So we'll just copy that over. We'll use the equals and point to that cell to the left, and then as we pull across, each cell is going to point to the one just to the left of it, and that'll work correctly. Those columns need to be a little wider, so we'll highlight them all, double click on that cell, or just pull it over and it'll pull them all over to make them the right width. And we have one kind of final consideration, that after we've been paying off these loans, we know we're only going to be there for 5 more years, so we're going to have to pay off that loan. So if we had kept the old loan, we would have had it for 13 years total. Remember, the original 8 and then 5 more years, and the new loan we would have it for just 5 years. So we'll use that same present value function we did earlier to get the payoffs, and we're going to use a present value of the original loan payoff after 13 years, and the present value or the payoff on the new loan after only 5. So let's do that PV function, and we're going to use the old rate, which was that 6% rate, divide it by 12, and our number of periods are going to be our 30 minus the 13, and then our payment is going to be that old payment of the 1618, so we'll just point to that cell up there, and this is going to show you, and then we'll just close our parentheses after that, and that'll be the payoff of our, oops, I forgot to multiply that by 12, so we have to put 30 minus 13 times 12 is going to give us our number of months. If I had done it the other way, it would have been years, and that's why we had such a low number. So our payoff on the old loan after 13 years is 206, and now we just need to do the same thing for the new loan, and that new loan is going to be equals the present value, and then we're going to pull in the rate, the new rate, 4.5, and divide that by 12. And we're not going to forget it this time. It's going to be our 30 minus our 5, and to turn that into months, we're going to go ahead and multiply that by the 12, and then we're going to get our payment from our new loan, which was that $1,200.77. And this is going to be the payoff of the new loan after only 5 years. Now you notice we got about a $10,000 difference between those old ones, and the new loan is going to be higher. That's a bad thing, because the decision we're looking at is comparing the old to the new. So we're just going to take the new minus the old, and it's about $9,300, and that's a negative number. If we do the new loan, it's going to be worse, $9,000 negative. So now we're going to just copy that cell down here. We use equals and then point to that cell. And now for the today, it's going to cost us $3,100 each year. 1, 2, 3, 4, and 5 is going to save us 5. But in that 5th year, we also have to pay out an extra $9,300. So let's sum all these up. We use our sum function in Excel. It'll highlight automatically those cells. Then we'll grab that little corner square and pull that over, and it'll automatically copy those formulas for us. Let go, and there you go. It gives us a total for today, and then each of those 5 years that are going to be after we make this decision. Alright, so is it going to make sense? Well, what we need to do really is a net present value calculation, but since we don't know the answer to that yet, we're going to just calculate an internal rate of return. And with an internal rate of return calculation, we're going to see one of the flaws of an IRR function, and that is when we have a situation with both positive and negative numbers, you're going to see some kind of crazy ups and downs. In this case, it looks like 152% rate of return, but you notice we have a negative cash flow, positives, and a negative, and that's always kind of a danger sign. So what we want to do here is go ahead and do an NPV. It may or may not be right, but you can get multiple solutions with an IRR calculation if you have positive and negatives. So the safest thing is to always do a present value of those future cash flows. And a simple way to do that in Excel is to use the NPV function. So we're going to do a present value of all the future cash flows using the NPV function, and then we're going to subtract away that initial cash flow. In this case, we're going to add it since it's already a negative number. So we're going to add that $31,689.85, and we're going to end up with an NPV of $10,061. So this tells us that clearly we have a positive net present value, so we should, yes, go ahead and make this decision. Well, let's play around with it just a little bit here for a moment or two and see what happens if we see if we can make this IRR do some crazy things by changing some of these numbers here. Alright, let's change that rate to 5%, and we're going to see that IRR is 121. Let's change that rate maybe again, and we'll change that down. I'm just kind of experimenting here, making it 6%. And now look, we have an IRR which has an error, and we have a negative NPV. And let's change it around a little bit here some more. If we go up here, change that initial rate. And in this case, we're going to go ahead and change the new rate to 5.5. And so it'll be an old rate of 6, a new rate of 5.5. We'll leave everything else the same here. And then you're going to see a situation where we have a positive NPV and a negative internal rate of return, which is impossible. The definition of internal rate of return is or an NPV is the IRR is the rate of return where NPV equals 0, and anything with a positive NPV would need a positive internal rate of return. So this just a caution about always looking at internal rate of return. You need to make sure that your cash flows don't have both instances where the cash flows go both positive and negative. Excel will either error or sometimes give you misleading answers, and I would encourage you maybe to do a Google search for internal rate of return problems in those cash flows. But if you use a net present value calculation, or just simply do the present value of all the future cash flows and then add those up, compare those to the investment. The investment in this case is the $31,669, and if we did a present value of that first year, second year, third year, fourth year, and fifth year, those are going to add up, and that the sum of those present values is going to be the $1556.93 when you subtract out that today's value. All right. Well, hopefully this exercise kind of helped you understand how to make a refi decision, and also helped you understand a little bit about making just general finance decisions and the difference between NPV and IRR.